Hello, my name is Julian Bates, and I'm the founder and CEO of Vizer Tech. I started Vizer Tech after the United States Patent and Trademark Office awarded me a patent in 2017. As far as my background, I'm a mechanical engineer. After I graduated from Wayne State, I worked at companies like Ford and FCA in product development, and I worked on parts like clutches and powertrain components, similar to the patent. Similar to the patent that I have already, so I'm familiar with the area. The problem that I'm solving with Vizer Tech is the problem of fuel efficiency. In this transmission right here, you can see a lot of the parts and components that eat up at fuel efficiency, such as clutches, bearings, and gears. The particular clutch that I have a patent on is the one-way clutch. And currently on the market, there are two types of clutches that compete with mine. First is the sprag clutch. In this animation, you can see the several sprags between the inner and outer race. These sprags are expensive, high tolerance parts that rely on friction to operate. And since they rely on friction, they eat up at the fuel efficiency. The other clutch that we compete with is the mechanical diode clutch, and I actually have this clutch right here with me. As you can see, it rotates in one direction and it locks up in the other rotational direction, so that's why they call it a one-way clutch. My clutch design connects and disconnects selectively. So upon disconnecting, there's no drag or frictional losses, and that's where the fuel efficiency benefits come in. And it does this with no hydraulic or electric actuation, which keeps the design simple and is patent protected. Here you can see the other two clutches' energy loss. The dotted line is the sprag clutch, and the black line is the clutch I just showed you. In my clutch, it has some energy losses at low speeds, but after a certain amount of RPM, there is no energy losses. As far as the competition, my clutch is an improvement in cost, fuel consumption, friction, and wear, but there is a negligible noise there. So in a transmission, in a closed assembly like a transmission, there is no real noise issue, but noise is there. The clutch was designed for fuel efficiency with a patent, and that's how it was designed. But there's also a benefit of only 4 total parts. So with that benefit of only 4 total parts, the competition part that I have right here, this is 28 parts. So that's a big value add. And only having 4 total parts allows engineering to improve in weight and cost, which saves in manufacturing and time. The development status, I have a 3D printed prototype. I have it here with me. Judge, you can see it in the front row. That basically that has 3 discs and a wave spring. As far as my background, I'm very familiar with the automotive industry, so I know what parts this clutch fits in the car. So I've worked on the GM and Ford 10-speed transmission, which GM and Ford worked on together when I was at Ford, and they sold about 2.1 million of those in 2018. But I'm also looking at starter motors, which are a smaller market, but they're used in almost in every conventional car. But the start-stop systems is what I'm looking to get into, because those systems are also looked to save fuel efficiency. And also hybrid gearboxes this clutch is used in. So that's 3 different components in the vehicle that my clutch is used in. But there's also a lot of other applications. My background is automotive, but since I've gotten this patent, I've realized there's a lot of other applications outside of the automotive industry that my clutch fits into, such as electric motors that need to overrun, wind turbine gearboxes, eddy current clutches, bicycle wheel hubs, helicopter rotors, revolving doors, cable reels, and miniature applications like printers and ATMs. So as far as, this is my proof of concept timeline. Right now, I'm at milestone 2. Milestone 1 was getting my 3D printed prototype made. So in milestone 2, I'll be fitting my clutch into different applications that I mentioned earlier. And based on the customer discovery I've done, milestone 6, they will all want to see test data. So nobody said I had to have an ugly baby. They just want to see test data based on what I got. So, and I already mentioned my background, and this is the lawyer I work with. So, does anybody have any questions?
All right, big round of applause. Thank you. Before we turn it over to the judges to ask you questions real quick, for those who are new here, this is a pitch, but we do not ask for money at the end. Reason being is because you're not technically supposed to in a public solicitation environment. That's the message from our lawyers. So here's the way it's going to work. I'm going to hand the microphone over to the judges. They're going to ask questions. You can answer them. Sound good? Great job.
Yeah, sounds great.
Okay.
Can you hear me? No. Can you hear me now?
Is it on?
No.
I don't know if I can.
Probably not.
I think it is turned on. Okay, cool. So, why did you start the company?
Well, I became familiar with the part, and I knew it was really popular based on my experience when I was working in a research and advanced engineering department. And I knew I felt like I could improve upon the design, and so I went at it, and I actually was awarded the patent. And when you have a patent, you can basically either license it or manufacture it. So I decided to make a plan to commercialize it.
So just want to compliment you on showing us the differences between the parts, because I would never have known what the different clutch pieces would have looked like. So thank you for that. But you talked about a lot of benefits, and you talked about energy savings. And what other, so you gave us a number, but I'm not sure I can equate it to, if you're not using energy for the clutch, where else would that energy be deployed to? So what am I gaining from the energy savings from the clutch?
So from a qualitative or a quantitative, a disconnect system is aimed at improving a vehicle's mile per gallon by around 1 mile per gallon with just my clutch added to it.
Okay, so 1 mile per gallon, or if it was a hybrid, okay.
Yes.
Okay. And are there other, from a cost perspective, can you give us a sense for how much the cost savings you think you'll be able to deliver?
So I believe there's two business models, licensing and manufacturing. So licensing, I know that's not cost saving, but I project to license it for about $1 per unit. But as far as cost for manufacturing, I got a quote or estimated cost to manufacture high volume at about $39. And I believe I could sell it for $47.
So if you can produce it for $39, what does it cost for the OEMs or tiers to produce it today?
Conventional clutches, that's around the same price. However, it's very complex, and I'm not there yet to be able to quote that exact number unless I get like high volume manufacturing number. This is just like plastic 3D printed prototype. So I'm not really there yet, but I do expect to be less because this is 28 parts. The competition is 28 parts, and it's a very popular clutch. And my clutch is only 4 parts. So from an engineering standpoint, there's always room. We can figure out how to make it cheaper just because it has a lesser number of parts.
Thank you. So you have a lot of opportunities for where you see this part being used. What's your initial go-to-market, do you think? How do you go about that?
My initial market would be starter motors. A starter motor is very small. Anybody can hold it in their hand with one hand. Some of the other applications I looked at were like transmissions and hybrid gearboxes. Those are like big assemblies. Like I could buy, I'm planning to buy a starter motor soon and start redesigning my design to be able to fit in the starter motor. And then it's pretty popular. Almost every gasoline car uses, any car that has a combustion engine uses a starter motor. So that's my like beachhead go-to-market plan is the starter motor.
Do you have your plan for how you're going to get your customer discovery then and into, get your contracts with some of the automakers that are making those parts?
Oh yeah, like I was saying earlier, like, and this is the plan, and like, so this is basically a commercialization plan, which basically at the end of the road is data, getting test data, which I can present to the customers in a report. So they've all seen my patent. Nobody said I have an ugly baby. They just want to see proof that it works, and that's how it works. I've worked in the industry as a test engineer, and there's nothing on paper or what you can say verbally. It's all based on factual data, analytical, analysis. So you basically have to just test it, till it breaks, and they want to see those numbers to be able to move forward with a contract.
When you were analyzing the market, you obviously saw the OEM. Do you think there would be opportunity for aftermarket for used vehicles, or would this strictly need to be used, the market would only be OEM, original equipment?
Well, like starter motors, there's always replacement. There's people in here who probably had to replace their starter motors, so that's like, an aftermarket type of application, which might not be the original part supplier that the OEM used. So yes, so starter motors are, that's a pretty simple OEM and aftermarket part. And plus, a lot of people have these cars where they stop when they stop at a light, the engine stops, and that's what the part that controls that is the starter motor. So that's another benefit to get into that market, because that part is also helping improve fuel efficiency when it stops the engine at the light and then starts it right back up.
So you believe the clutch could be used in used vehicles on the road?
Yes.
For repairs?
Any other questions? Oh.
One more.
So that proof of concept data, is that just going to be for automotive, or can that data be used for other industries?
Yes, they all have different tests. So like Chrysler gave me a list of tests that they want to see me do. But like, let's say if we go with the other applications, like a wind turbine gearbox, they would have a completely set of different tests, and the clutch will be different too, because it's like it's different size. It's not like a one size fits all. So every application will have like a different set of tests, because it would be a different clutch for the most part.
Awesome. Thank you so much.
Thank you.